and I want to welcome you to a demonstration on the independent t-test in SPSS version 27. Let's start with some interesting history of the name t-test, or as it's sometimes called, student t-test. The student t-test was a new mathematical approach discovered by William Seeley Gossett using very small sample sizes. Gossett worked at the Guinness Brewery in barley research and wanted to publish his findings. Guinness considered his work a trade secret, but did allow him to publish under the name Student in 1908, thus the student t-test. The independent t-test is a parametric test. It compares the means of two independent groups to determine if there is a statistical evidence that the population means are significantly different. The null hypothesis shows the mean as equal. The alternative can be not equal, which is a two-tailed test, greater than, which is a one-tailed test, or less than, which is a one-tailed test. Let's look at an example based on a real study from the Journal of Purchasing and Supply Management, looking at annual salaries of purchasing managers for males and females to determine if there is a significant difference. The actual study has over 300 data points, but for demonstration purposes we will work with 10 men and 10 women. The data requirements listed here must be met in order to conduct this test. First, let's look at the hypothesis. The question is about salary for each population, or each sample. Mean 1 is for males and mean 2 is for females. The age-old question, are men still paid more than women for comparable work? Now, let's translate that question into a hypothesis. The alternative hypothesis is mean 1 minus mean 2 is greater than 0. This is a one-tailed test, or right-tailed, because the sign is greater than. Next, we go to the method and ask 4 key questions. Are we hypothesis testing? Yes, we are. Are we using sample data instead of experimental data? Yes, we are. Do we have one numerical value? Yes, we have salary data. Do we have two independent samples? Yes, we have male and females. Next, we go to check. We have to check the data for a normal distribution looking for outliers. Now, from the study with over 300 data points, we know the samples were independently selected based on what the researchers discussed. For demonstration purposes, let's assume that the salary distribution is normal for both males and females. The box plot shown here does not show any outliers, so we should be okay. Before we go to SPSS, I want to demonstrate that you can run a t-test in Excel. Let's look at each formula. In cell B12 and C12, we calculate using average. In the next cell, we calculate standard deviation using the function standard deviation. The variance is just a square of the standard deviation. We calculate the t-value using the formula shown here in black. The absolute or calculated t-value is 3.11. The numerator and the denominator of the formula are shown so you aren't trying to piece through an entire formula in one cell. The p-value for either a two-tailed or a one-tailed test using the t-test formula is demonstrated here. Remember, when you calculate value or absolute value, if it's greater than the critical value, that's the one we look up in the table, it's significant. So we would reject the null hypothesis. So either the p-value can tell you there's a significant difference, or you can compare the calculated value, or sometimes referred to as absolute value, to the critical value found in a table. Here's a table for an example. At 18 degrees of freedom and an alpha of 0.05, we see a critical value of 1.734, or even at an alpha of 0.01, we see 2.552. Remember, if the calculated t is greater than the critical value in the table, it is significant and we reject the null hypothesis. In this case, we reject the null hypothesis. So now let's look at this independent t-test in SPSS version 27. Okay, so in SPSS we click Analyze, Compare Means, choose Independent Sample t-test. Salary goes in our variable. The grouping is done on gender and we define the groups. And we want to make sure that the estimate effect size is checked. We say OK, and we now have our output. Let me move it over here a little better. And now let's review this output. Our output first shows us a Levine test for equality of variance. Since the significance column is above 0.05 at 0.174, we can use the first row because we can assume equal variances. The t-calculated statistic is 3.11 with 18 degrees of freedom. And a significance for a two-tailed test is 0.006. So a one-tailed test is 0.003. Now, version 27 of SPSS shows us the effect size. Effect size is important because it tells us that the effect was not due to chance. I've put the descriptive section of the test here so you can see the standard deviation for males and females. SPSS automatically calculates several effect sizes depending on the circumstances. Cohen's d, the most popular one, is for two groups that have similar standard deviations and the same sample size. I feel like our standard deviations are too different to be considered similar. The Hedges correction, you use this when you have different sample sizes. So you might have 20 males and 10 females in the study. That's not the case here. We have the same sample size. The Glass delta, use this if each group has a different standard deviation. And yes, I think this one fits our study. Before we move on, just know that Cohen's d breaks down the statistic into what it considers small, medium, or large effect. And additionally, there are tons of online calculators that you can use to calculate effect size. But version 27 calculates all three effects, the Cohen's d, the Hedges correction, and the one we're using, the Glass delta. Since it is over 1, that means that there's a difference. The difference between the two means is larger than one standard deviation. Now let's go to the write-up. In this write-up, we're using APA 7th edition as a guide. Notice that we convey the means and standard deviation, the 18 degrees of freedom, the calculated t, and the probability that shows significance. We also share the effect size, including a small explanation. The next slide shows the t-test table according to APA 7th edition, along with the output tables from which the table data was pulled. As a caution, review the latest APA edition guidelines and remember that the output from your statistics software may not follow APA, probably will not. You can download a Word template from APA that has the sample tables, and I've given you that link in the slides. And in closing, here are some references. If you need more explanation on effect size, try the Lakins article. And if you are interested in the salary survey, the real one, look for the Larson and Morris article. And finally, don't forget to check out the Social Science Statistics website or the effect size calculators. You can just search on them if nothing else. Thanks for listening.